Hello, Calculus student. This video is for Calculus 1 review, and we are going to do an example for derivative, integral, and including definite and indefinite, and also use substitution in finding tangent line. So if you want to go over the formulas, use the last video. Okay, so example 1, find the derivative function of each of these. So that we will just be applying the power rule. So we know the power rule is d dx. If I have x to the n, the derivative is n x to the n minus 1. In particular, d dx of a constant is 0. K is 0. Okay, so and if I have a multiply, for example, if I have a constant multiple of k x to the n, then this constant is different. This just multiply in front of it, k n x to the n minus 1. Okay, so f prime of x will be d dx, right? So we'll do d dx of this one. So it'll be 8 times 3, 24. But the power of 3 will minus 1 will become 2. Minus, so this one so maybe I'll just write all of them instead of doing it right away. I'm going to write all of them as a rewrite first. So this is a step that is rewrite. I'm not doing a derivative, so it'll be x to the cube. That's a good power. Minus 5 x to the power negative 1, because 5 over x is the same as 5 times 1 over x. So right here, 5 over x is actually 5 times 1 over x. Do you agree? 5 times 1 over x means 5 times 1 and over x. So 1 over x is 5x to the power negative 1. So why do I write it this way? Because it's x to the n. Plus 3 square root x is x to the power 1/2 plus 2x plus 1. Okay, now these are all x to the power something, and this will be 0. So now I'm going to apply the power rule. So this would equal to 24, but x is square because 3 minus 1 is square, minus 5 times negative 1 will be negative 5. And then x would be to the power negative 1 minus 1 is negative 2, right? Plus 3 times 1/2 is 3 over 2. 3/2 times x, 1/2 minus 1 is negative 1/2, right? Plus 2 and 0. So this is nothing. Now we're going to rewrite, right? So f prime of x, you need to rewrite it back to the radical form. So this one had nothing to rewrite. This would be plus 5 over x squared, because we don't want to have any negative exponent, plus 3 over 2 root x. X to the 1/2 is root, negative is in the denominator, plus 2. So that is our answer for f prime of x. The second one is a practice of trig function and also chain rule. So do I have to rewrite anything? Maybe I'll do rewrite first, so it is easier to do. So I will write it as sine 2x plus cosine square x actually means cosine x but square. So it's easier to think of it that way. And then this is cosine x squared. So you can see that the inside function for this is cosine x. The outside is something square. But versus this one, the inside function is x squared. The outside is cosine x. Plus, this would have both of them mixed together. Will be 7 sine x to the 4th. But this whole thing is square. Sine square means sine x, sine whatever you have square. Now we can see all the inside and outside, so we're going to do g prime of x, use chain rule. The outside is sine, so I just do a cosine of it. And then I need to multiply what is inside. The derivative of, maybe I'll just write d dx 2x, right? And what is the outside function? The outside function is something to square. So I would say 2 cosine x to the power 1, and then do d dx of cosine x, the inside function. You can see that the inside is cosine x plus, what is the outside function? Is cosine. So I have to do, yeah, cosine. So the cosine is cosine, that is negative sine. Keep the inside function, but now I have to multiply d dx of the inside, which is x squared, plus, the last one is kind of difficult. So the outside had a constant 7 times 2 is 14 of, outside is sine, so it will be cosine, no, outside is, this is actually more than 1. So outside is the something square, so sine x to the 4th to the power 1, and then d dx of sine x to the 4, right? Times, this is time, not adding. Now I'm going to rewrite it or do the chain rule of the second part. So cosine 2x times 2 will be d dx of 2x is 2. So I'm going to move it to the front. Be 2 cosine 2x. And actually, whenever we see sine kx, we can just do k cosine kx. Plus, so this is done. And then we do the derivative of cosine is negative. So be negative 2 cosine x sine x. Right? This is negative sine x. And then what about this? This would be a minus, right? Plus and minus. It's kind of strange. What is d dx of x squared is 2x, right? Minus 2x sine x squared. This one is kind of difficult. It's 14 sine x to the 4th plus 14 sine x to the 4th. And then I want to do derivative of this. This is the has an inside and outside. Outside is sine will be cosine x to the 4th, right? I keep the, and then time d dx of x to the 4th. Sorry, this run into each other like that. And I want to finish the last one, so I'm going to do this, copy this again, 2 cosine 2x minus 2 sine x cosine x, or cosine x sine x, there's no particular order, minus, okay, minus 2x sine, okay, so minus 2x sine x squared plus, oh, this one is really long. So 14 sine x4 cosine x4, but the derivative of x to the 4th is 4x to the cube. Okay, 4 times 14 is 56. X to the cube, we want to move it up, right? And then sine x to the 4th, cosine x to the 4th. The last one is kind of tricky. So that is the derivative of g of x. Next one, h of x is e of x tangent x. So I see two functions, right? These are not chain rule. Do you see that they are not inside, outside? When I have sine 2x, I see 2x is inside a sine, but this is just two products. E of x is one function time tangent x, whereas sine 2x is not sine and times 2. Right? They are inside, outside. So this is f of g. So I would say, do I have to rewrite anything? I don't need to rewrite. So h prime of x would equal to, I fix e of x first, and I do d dx of tangent x. And then I plus, and then I fix tangent x, and then I do d dx of e of x. That's product rule. So e of x multiplied to, what is the derivative of tangent x is secant square x. And what is the derivative of e of x? It's e of x. So some people would see, oh, both of them have e of x and just factor it out, but you don't need to. You can just give the answer in the last one. Now, this is also a quotient. a function and another function. They're not inside or outside of each other. So it's like the f and g function. So we use quotient rule. Now, if your function is 2 over x, can you say that, oh, I have a f and a g? You don't need to, because you can just write it as 2x to the power negative 1, right? Because 2 is a constant. But if this is actually a function, then you should not. You would just use quotient rule. So for quotient rule first, I would say g prime of x is equal to, I would write ln x square, and then have the ln x to the top, d dx of the numerator minus x, and then d dx of the denominator ln x. So write it out first and then do it. So ln x square is still ln x square. ln x times d dx of x, that is 1, right? So that means ln x times 1 minus x times ln x is x times 1 over x. That cancel each other. They go to 1. So that is ln x minus 1 over ln x squared. Now you can cancel them because they are two terms. So that's the final answer. Let's do integral and also definite integral. So for integrals, we would just do a rewrite first. X to the 3 is good. I don't need to rewrite. Sine 3x, I don't need to rewrite. 1 over x, I don't need to rewrite because I don't use power rule. But x square root x, I write x1 half dx because I would need to use power rule. So this would be power rule x fourth over 4, because 3 plus 1 is 4 over 4 plus, oh no, this is not plus. This is a minus cosine, because the integral of a sine is negative cosine 3x. But because you have 3x, you have to do the reverse of chain root divided by 3 minus integral of 1 over x is ln x plus, so 1 half plus 1 is 3 over 2. And I divided by 3 over 2 becomes 2 over 3 x to the power 3 over 2 plus c. So the final answer will be x4 over 4 minus cosine 4x over, no, cosine 3x over 3 minus ln x plus 2 over 3, or 2 x root x, because x root x, 3 over 2 is 1.5, right? So it'll be 1x and a half over 3 plus c. Okay. You can leave it this way or write it as a radical. You can also write it as x3 root square root is also fine. But remember to divide it by 3 over 2. And if you divide by 3 over 2, you flip over. So it become times 2 over 3. Because 1 over, so this is the reason why I have 2 over 3 is 1 over 3 over 2 is 2 over 3. It's the reciprocal. Okay, let's do a integral of sine 3x, the lower limit pi over 4, upper limit pi over 3. So that is equal to cosine, sine is negative cosine 3x over 3, upper limit pi over 3, pi over 4, right? So this means negative 1/3 cosine pi over 3 times 3 is 3x, right? My mine yeah, minus cosine pi over 4 times 3, right? And then we would need to do the unit circle, so this would be negative 1/3 cosine pi minus cosine 3 pi over 4. And the unit circle, if you look up the unit circle, cosine pi is this point This point is -1, 0, so cosine, this is cosine pi. 3 pi over 4 is, where is 3 pi over 4? Still over here. So it's -√2 over 2, right? And √2 over 2. So 3 pi over 4 is -√2 over 2. So it's -1/3, -1 minus -√2 over 2. That's a lot of negative. So if you multiply this in, so it would be 1 plus, 1/3 plus, so √2 over 6. Okay, so that would be the final answer. You need to know the unit circle really well by, yeah, because we no calculator, okay, you want exact value. Okay, yeah, the is the plus. Oh, this is actually a minus because if you minus a negative, is a plus, and you multiply. Yes, I made a mistake here. It should be 1/3, but really minus √2 over 6. Okay, so so 0 to e of -2x. So the integral of, you go to -2x is e of -2x, but divided by -2, and we plug in from 2 to 0. So that means I am factoring -1/2 out, and then I have e to the -2 times 2 minus e to the 0, right? So -1/2 e of -2 means 1 over e square. Ooh, 1 over 2. Oh, 2 is 4, e to the -4, right? Minus e to the 0 is 1, but I multiply by 2. That means 1/2 minus 1 over 2 e to the 4. That's the exact value. Okay, let's do some indefinite integral. So this would be a square. I'm going to use dx a square plus x square equal to 1 over a arctangent x over a, right? The 4 we would just move it outside. So 4. So be our a is 4 over here. Times 1 over 4 arctangent x over 4. So that would be arctangent x over 4. Oh, plus c. Okay, how about this one? I will have a equal to 2, right? So this would equal to 1 over 2 arctangent x over 2, but integral or substitute 2 to -2. So I would have 1/2, which is outside, and then I would have arctangent 2 over 2 is 1 minus arctangent 2 over -2 is -1. What is arctangent 1? That's pi over 4. What is arctangent of -1? Is negative pi over 4. So this would be pi over 4 plus pi over 4, that's pi over 2. 1/2 times pi over 2, that is pi over 4. Okay, use a substitution integral. So maybe I'll do this in the next video.